Okay, morning everybody. We'll kick off because we've got lots of slides to go through. My name's Steve Sharman. I'm going to be doing most of the talking this morning. Russ is going to be running some demos for us. For those that are English, I was going to do a picture with him as Debbie McGee, but I thought that might break some copyright rules. So the idea of the session today is that we're going to do lots of demos as we go through. There are loads of slides. You should hopefully have the slides already in the app. And you've got all the hidden ones as well, because when we looked at the amount of content and we thought it's 2 hours, we thought it's not really going to work. So you've got all the hidden slides that we've done, but fingers crossed, Wi-Fi staying up. We'll just do lots of live demos as we go through. Obviously, it's a big room. If there are questions and time permits, then by all means ask them. But if I'm running late, then I'll just kind of halt the questions and we can do them at the end. Okay, so hopefully you all know why you're here. So we're going to look at really use cases today. So we're going to use Postman, we're going to use UCS Director, we're going to use Cloud Center, we're going to use Ansible, all different ways to configure the network. Some of the use cases are from a customer as well. In fact, 1, 2, 3 of the use cases are from customers that we've done. So they are real world. They won't match everything that you'll possibly want to do, but hopefully they'll give you somewhere to go from, like a starting point. And hopefully at the end of it, you'll have an idea of how to start automating the network. You'll have an idea of how the API works and how we can start doing things differently, quicker, how we can start giving boring jobs away to other teams to do as well. So as I've said, my name's Steve. I've been at Cisco for like ages now. I think 20 years, I think it was last year. Oh, yes. So into the 21st year. I work for the European DC team, and for those that have seen me in with different customers, I do very much more applied stuff, so actually how things work as opposed to part numbers. Don't ask me a part number because I'm rubbish with the part numbers. And Russ?
Yeah, hi there. So I'm Russ Whittier, so same team as Steve, and again, being at Cisco, I've been here twice, so this tenure is 14 years, 2 years before that, and a startup in between. Done everything from ACE load balancing, firewall service modules, security, and now I'm part of the data center team doing automation. Specialized over the last few years on UCS Director, but encompassing anything with automation and lots towards ACI, because it's very programmable.
Okay, so the agenda today, we're going to look at why you'd bother automating. I've included an ACI primer just so that everyone is kind of on the same page. Everyone understands, I guess, where we're coming from. Then we'll look at the policy model, and then we'll go through these use cases. And as I say, fingers crossed, while it's working, we'll just do the demos live. Worst comes to the worst, we've got videos, but videos are no fun. They don't get you nervous when you're on stage. Okay, so sorry, go back. So the obvious question to start with, which is, why are customers looking to use automation in the data center? What's the real driver for changing the way that they've done things for years and years? Historically, you would have done command line, you've done a bit of cut and paste, change some config, throw it back into the CLI. But through the tools that we've got now, you can really start automating and doing things a different way. Now, there are loads of reasons why you would want to start automating. The one that I always talk to customers about is doing change control during the day. So instead of saying, my changes happen on a Friday night or a Sunday night or of an evening, really what we're looking to do through automation is enable you to do changes whenever you want. Because you shouldn't have to wait. If you go to a cloud provider, you don't ring up AWS and say, can I have a firewall change? And they'll say, yes, it'll be ready on Sunday night for you. They'll do it there and then. It's a fully automated process. And we do now have the tools available to make our own internal networks operate in exactly the same way. So that's really the aim of the presentation. That's what we're going to walk you through. Not only is change control, I guess, a big area to consider when you're looking at automation. One of the things, as Russ and any of the other Cisco guys know I'm quite keen on, is having things very structured. So a very structured naming convention, so that when we send config in, there's no errors. We're going to give you some very limited amount of fields or information that you can fill in. Everything is then delivered in an automated way, which means you've got obvious configuration. You know, you've not got people that will do things subtly differently, so we'll try and keep everything the same. But automation means very different things to different people, and it definitely depends on your starting point. So I don't know where everyone is in this room, if you're all network people or if some of you are sort of DevOpsy people and some are dabbling with some automation, but your starting point tends to be very different. And some customers tend to be very open and accepting of automation and accepting of letting other people do what has historically been their job. And then you get the opposite side. You'll get people that are like, well, I'm not going to automate because that's my job. I've got my qualifications. I will sit there and I will go on the command line and I will configure everything myself, and I will own that. And they're very different mindsets. When you look at the two people and look at the two ways that they work, historically, all network people have been really change adverse. You know, it's risky. You've got a change window. If you make a mistake, you need to back out and then go back in and fix what you've just done. And it's very much been a siloed approach. So the network itself was this black box that everyone runs on. But as I'm sure you all know, the first thing when anything goes wrong is it's a network fault. It's not a database fault or a firewall fault. It's always a network fault. It's always the network team that's the problem. So what we can do, hopefully, at the end of this presentation, is show you a way that you can actually change that and make it so that thought process of, here's my change, I'm going to implement it in 3 weeks' time, we can look to do that a different way through automation. On the flip side, the DevOps mindset is very different. And we see this actually with some of our own products that are on a very much a DevOps kind of life cycle, in so much that when changes are made, they just go live automatically. And it almost doesn't matter if it goes wrong, almost, because people moan, obviously, but it's almost expected. It's a very fast release cycle of changes that are going on within applications. And this is why, you know, lots of people have used clouds, because they'll go and use somebody else's network. So they'll go and deploy elsewhere, and they'll use their automation, because internally, I don't think we've necessarily adopted all the tools that we could do to drive change within the business. So two very different mindsets that we see. And I personally think, and those that have, again, seen me in their customers, I think we should, as network people, delegate control to other people. So I don't think that security of an application should be a network team's job. I think that's the application owner's job. Because if you go to a cloud provider, you know, there's no firewall person that sets that up. You do that. As the app owner, when you deploy the app, you set up your security rules. So if we can change and let the network operate in the same way, then actually what you start to see is a proper internal cloud. I'm not going to read the whole quote to you. I'm just going to pick out the line that's underlined. So it says, if developers don't like a product, they won't use it. And this is very, Russ is laughing. This is very, very true. We did a demo for one of the TV broadcasters, and we used UCS Director. And the use case that we'll show you with UCSD was the first use case that we've shown the customer. And they loved it. It was perfect for them. And then what we did is that we showed the same tool to a different team for a different purpose. And they're like, no, not interested. We write Python. And we're like, yeah, but look at this tool. It's got a nice web front end. You can put your values in and it will configure things. No, we write Python. So their answer was Python. I could have said anything. The answer was Python. So for them, the tool was of no use whatsoever. So very much it's a case of choosing the tool that fits the audience that you're going to, or the consumer of the tool. And so if the consumer is a Python house, which this broadcaster was, then they won't use a nice front end. However nice we made it, they won't use it. Because you can't force people to do it, and the kind of DevOps world, this faster world, definitely holds more weight now within customers, and they get listened to a lot more. Because it's like, if you can do it quicker, use whatever you want. Use the tools that you want. So don't try and force a tool, and we'll look at the different tools here. And it is important to understand up front that there's not one tool that is the right tool for customers. Just choose the one that is most appropriate. I think it's important to understand what's core and what's context for network people as well. These are just my thoughts on this. I don't think that configuring interfaces is really a core network thing. You know, when you plug your server in, when the server team rack their server and attach it to the switch, they then have to go to the network team typically to configure that. So if we can give that away, if we give that process away and let other people do that, you know, that's going to enable that team to be quicker with getting their servers attached to the network. So I think you can almost give that away. I think that routing, or routing, whichever you prefer, is very much a core network function. That is getting connectivity to your services. So I think that is absolutely a network function. As I mentioned before, I don't think security really is. I think that should go to the application owners. And fault finding and change control kind of go hand in hand, because you have change control because you're worried that things won't get deployed correctly or that you'll make an error. So then that leads you onto the fault finding. And your change window takes into account the time to fix what you've just done. Now, if we were to automate and have a guaranteed output from everything that you're doing, that means your window can shrink, and also means that your fault finding time can shrink as well. So it's a case of looking at what is core, what's the core things that network teams should be actually working on. So very much what I see across all customers, and I'm sure everyone in the room has got some cloud strategy, is that you'll have a team inside the customer that says, I want to go to a cloud. Now, they don't necessarily know why they want to go to a cloud, other than the first thing they perceive is that it's quicker. The next thing they generally perceive is it's cheaper. Whether that's right or wrong is a different matter. But what is key is that they're in control. So that team of DevOps people, that team that's deploying applications, once they start using clouds, then they're in control of what goes on. And I think that internal network teams have kind of got two choices. You either accept this and think, OK, that's fine, they can just go and do whatever they want, whether that's run a network on top of your existing network, or whether that's run a network up in a cloud. Or you can say, OK, well, how can we support you? How can we help these DevOps people to actually do their own network, do their own deployments, whether it's something as simple as standing up some virtual machines and applications and then configuring the security rules. Because most application owners only care about really three things. They care about the IP address, they care about the default gateway, and they care about who can talk to them. They don't care about bridge domains and tenants and EPGs and all these different things. They just care about what's my IP, what's my gateway, who can talk to me. That's it, connectivity. So really, what we want to do is let the network team offer those services, or offer up the network, if you like, as just an internal cloud that can be consumed. Now, there are loads of tools out there that you can use. We're going to use, in this demo that we're going to do, we're going to use UCS Director, we'll use Postman, Ansible, and Cloud Center. So they're the tools that we will use. And there is absolutely overlap between these tools. And I've kind of picked away, and we've built the demos of how we're going to do them. But for example, UCSD, you could do a lot more than we will show you in the demo. So that will configure lots of different stuff, whether it's servers, compute, network, etc. We're going to use it to do one thing, which is configure network interfaces. We're going to use Postman. We'll see how we can configure subnets on a fabric. The Ansible one is the one that caused us the most fun, shall we say? Or as it was last weekend, I know Russ was working on stuff. I was both working on stuff on Sunday to get everything ready for you today. And Cloud Center is kind of the opposite end of the spectrum. So Cloud Center, this is really hands-off from a network team. The network team is just going to provision subnets and connectivity, and then go, that's it. Just lay down your applications, configure your own security rules, and we'll show that with Cloud Center. But they all overlap, and that's quite important, and very much choose the tool that matches your use case. So I am going to do a quick ACI primer. When we did this session last year, somebody said, oh, we already know ACI, that's why we're in the session. But I'm going to cover it off anyway, just so that everyone is on the same page. So the building of a fabric, everyone's done before, and I've used this slide for years now, so we won't drill into it in a lot of detail. What I'm going to look at is the management options that you've got. So when we configure the fabric, we can configure the fabric in lots of different ways. And everyone will start off using the GUI. And that's the way that people have always started. Absolutely fine. You'll either love the GUI or hate the GUI or tolerate the GUI, depending on where you are in that. We have the command line, and I do very little troubleshooting on the GUI. In fact, I would say I really don't do any troubleshooting on the GUI. I would use the CLI, because I can type it in much quicker than I can go onto a GUI and point and click and find the screen that I want. When I come to doing config, I probably use Postman the most. That's probably the thing that I use most, because it's in our environment that we've got, it's not, well, we don't really do change control properly, do we? We have a phone call that says, I'm making this change, is that all right? And it's like, well, I guess so. Or there's no phone call, and the change is just made, and we hope that nobody else was affected. So I use Postman a lot for doing things. It's quick, easy, it's pretty dirty, if you like, for doing changes. But you can wrap that up, so then you could start using things like Ansible and fronting that with Tower, or fronting that with ServiceNow, and start delivering things out of a catalog. So there's no, I guess, right or wrong. Just pick the one that you're most happy with, and choose other tools or other interfaces that customers can do. Now, when you come to configure a network, really what you want is consistency of config. So you want to know that everything that you've configured is configured in the same way, so that if you're looking at the name of a filter, for example, it's clear from the name of the filter what that filter is going to do. And if you just let people do things manually, there will always be discrepancies. There will always be things that aren't quite the same. So if we actually script that or automate that, then you can drive that consistency of config. And then what you can start doing is pulling config out of the network and presenting that automatically into your CMDB, or pulling that automatically into just config that your help desk team can see. So we really structure the config in a lot different way. Now, obviously, networks can grow really large. And generally speaking, when customers start with ACI, unless they've both feet in at the deep end, they start off quite small. But the larger your network grows, the harder networks become to manage and to look after. So if we start with this view that we're always going to start with automation and not start by doing things manually, then as the network grows, you'll be in a much better place. Often customers think they'll do automation as a secondary. So they'll think, OK, I've got my network in now. What I want to do is now automate it. But I think that's really the wrong way round. What you should be doing is getting your network in place, and we'll actually almost see this on one of the demos. So you'll put your network in place, and the first thing that you do is you build your automation processes such that when you roll things out, as the config grows over time, everything has been automated, everything can be undone, everything can be self-documented. And that's really where we would like you to get to. Click. Now, the consumption of model that we have with ACI, it does let you do things differently, as you will all know. The first thing that you need to do is you need to build your network configuration, and then the second thing you need to do is go and use it. And they're in different parts of the GUI, and we'll look at these very quickly, and I'm going to whiz through these slides. So the first thing is going to configure these interfaces, and anyone that's seen me present before will have this slide, or a slide like it, or something like it. But you absolutely need to understand how the relationships work between these objects. And as we'll see later on in the presentation, when I talk about the policy model, this is exactly really what the policy model is. This is the combination of objects, such that if I deleted an AAEP, which is just switch port trunk allowed, really, if I deleted that, then I've broken things north and south, because I've broken the connection between them. If I delete a policy group, that could be quite catastrophic if you wasn't really aware of what you're doing, because if everything used the same policy group and you deleted it, then you've broken connectivity for everything. So you very much need to understand the model and understand how you're going to configure the network. And there are two ways that we can configure the switches. The first way, or the first model, is the one that we'll see in the demos that we're going to do. And this is based on using the leaf profile based on the switches that we're talking to. So I've got some policy groups. They're for my ESX host, for my Linux host, for my Windows servers. And I'm going to configure individual interfaces on switches. So a very old school way of doing it. I'm going to take a switch or a pair of switches, and I'm going to say, configure port 1 for this, port 2 for this, port 3 for this, add the descriptions to it. So a very traditional way, excuse me, and we'll see this in the presentation. So the second option that we've got, excuse me one sec. The second option that we've got is that we're going to configure that based on the actual type of device that we're attaching. So in this case, I've based it on ESX servers, and all of the ports are now common for my ESX servers. So everywhere that I apply this policy, I'm going to configure the ports 1, 2, 3, etc. for ESX. So in a bigger data center, I would say this is definitely the best option, but you use both at the same time. And that's very, very common to see both models used. What's also, I guess, thought-provoking is that if I'm going to automate, then it really doesn't matter which model you use. You just pick the one that makes the most sense, you put it into your automation engine, and you'll spit out the config at the back end. But in this case, when I'm going to configure my switches 1 and 2 for ESX, I'll just put that policy onto those switches, or put that profile on the switches. If I want to configure 3 and 4, 5 and 6, 7 and 8, 9 and 10, and so on and so on and so on, I can just reuse this policy across the board. So 2 ways that we can configure the interfaces on the switches. Pick the one that makes most sense. One of my pet hates is really bad naming that customers do, because when you come to troubleshoot, it needs to make sense and be easy to troubleshoot. So think about the naming convention and do your planning up front. Because as soon as you start deploying things and you start using these policies, there's no renaming function. So if you want to go back 3 months, 6 months later and think, oh, I didn't really give that a good name, I want to give it a different name, then you need to have a good understanding of what will then be affected. So what's going to change when I delete this object and replace it with another one. Now, through automation, you can do that very quickly. It is click your fingers and it's done. But you do need to consider the naming convention up front. And that's not what customers generally do. They think, OK, I've got this new network, I've got this new toy, I'm going to start configuring and playing with some things, and they've got all sorts of weird naming. And I'm sure if we look in our lab, well, I'm definitely sure, because I did it myself the other day, I've got things called delete me and test tenant and things like that. So have a better naming convention. And then when we come to use the network interfaces, we absolutely need to plan how to do this. So the first thing that we need to think is, how do I design the tenants? How do I configure and design my tenants? And there are only 4 options that you can do. So the first option is that you put everything inside the common tenant. Nothing wrong with that. That's absolutely fine. The second option that you can do is that you can put your subnets and your VRFs in the common tenant, and you put your EPGs in a dedicated tenant. So I kind of split things, if you like. Network team does the routing at the top and the subnets, and then the application teams or the subset of networks, if you like, that you want to run on top, so production, pre-production, online banking, whatever they may be, you build the EPGs for those inside their own tenant. The nice thing about the second option, and we'll see it on a few slides' time, is for migration purposes, when you migrate from your current network to an ACI network, that's absolutely the model that you want to go with. I was with a customer just before Christmas that took the third approach, which is where they put the subnet inside the tenant, and then they found out they couldn't migrate services into different tenants. So you can see what's in common, but you can't see if it's down inside a tenant. It becomes not shared. The nice thing, though, with that model is that now that subnet is dedicated for a tenant, so nobody else can use their IP space. So there's definitely some pros and definitely some cons, depending on your starting point. And the last model that we'll look at is where we put everything inside the tenant. So the VRF goes in there, the subnets or the bridge domains go in there, the app profiles, the EPGs. I put everything inside the tenant. So what you need to do, or what I'm asking you to do, is to pick the model that makes most sense for your customers, your consumers of the network. Definitely, I would always my starting point with customers is always the second option, and then investigate the others to see where they make sense. So this is how we would do tenants, EPGs, app profiles, bridge domains, etc. And we've got the same for contracts and filters. So we can put them all in common. That's fine. We can put split, so we'll put the filters into the common tenant, and we'll put the contracts down inside a dedicated tenant. So again, the 4 different models that we can use. I would always recommend the second model. So put your filters in common, because the filter just says this source port to this destination port. So if I can put that in common, anyone can use that. It's just a resource that can be used. So it makes your config much simpler and much easier to manage. Your next consideration is should you use network-centric mode or application-centric mode. Now, I will totally get on my soapbox about this. Network-centric and app-centric is just marketing speak. It's just rubbish. It doesn't mean actually anything. What you should do is whenever anyone says this, is you just need to insert the word naming after every time you say it. So if I'm doing network-centric naming, it means that I've named something VLAN 10 or subnet 10. If I've done application-centric naming, it means that I've named it web app, DB, single sign-on, backend, database. It means that I've named the network constructs after the application. That's all it means. There's no difference than that. And it really is, I guess, a pet hate of mine that customers will go, oh, I'm going in network-centric mode, and I want to go to application-centric mode. It's like, OK, if I've heard that once, I've heard that 100 times. And I'll show you how you do this migration in a second. There are then only 3 deployment options that you've got for how you actually build out the network itself. So I would do what I call standard networking, where I've got a VRF, typically in common. I'll have my BDs in common as well. And then I'll deploy a single EPG per subnet. So very much traditional networking, 1 VLAN, 1 subnet on a VRF. That's very basic networking. I would say every customer does this. Very normal to do. The next thing that we can do is kind of the first type of microsegmentation. And what we do here is that we have 1 subnet, and now I've got 3 VLANs attached to the same subnet. Now, if you look at the marketing speak, they would call this application-centric and the previous network-centric. Forget that. It's just the names that you give it. There's no difference at all. But in this case, now I've segmented my subnet by just having different VLANs attached to it. So very easy to do, and very common. And customers start to do this when they look at a subnet and they say, well, I've got these different workloads. I'm going to separate these out into different groups, and then I'm going to give them names that mean something to me. And the third option that we've got is that I can have multiple subnets, so IP secondaries, on the bridge domain. So this is the third option that I've got. You've only got 3 options. That is how you configure the network. But customers say this, again, pet hate. They say, how do I migrate? I've started off, I've done this network-centric mode, at which point I punch myself in the head. And then they say, I want to go to application-centric. How do I now go to application-centric mode? So I normally start off with, OK, like, why? If it's working, why do you want to change it? They've probably got an answer, which is, well, we bought this network that's an application-centric network, therefore we must use this mode. OK, that's an answer. The second thing is, how long will it take to discover these application dependencies? So how do I discover them? How do I understand what's talking to what on the network? Obviously, we've got tools such as Tetration that will do that for you. But if an application has been running on the network for 10 years and it's got another 2 years of lifespan, then I would just leave it as it is. If you're deploying something new, then I would typically do it a different way. But the biggest thing for me is what's the operational impact? So when I do the change, what is then going to happen? How do I do that? What's the impact on the network, on the applications? But if you want to do it, this is exactly how you do it. You put your subnet and VRF up in common. You put your VLAN and your app profile down inside your classic, legacy, old, whatever you want to call it, tenant. And then you build your nice new tenant that's going to be my production. And I actually did this for a customer down in Joburg, and they were going through this exact process. So my app profile represents the subnet, and I've got VLAN 10 on the left. And then on the right, I've split it into web app and DB. And all I need to do is move the servers across. That's it. Put the contracts in place, reattach the servers to the different VLAN or to the different port group, and that's it. I've now moved from network-centric to from network-centric to application-centric. That's the extent of the change that I need to do on the network. And that's all enabled because you've put the subnet up there inside the common tenant, and it lets me move workloads between different tenants. And that's why I said before, you need to position your subnet or your BD up in common. The other thing that you need to consider is how you do security inside the data center. So do you horizontal stripe it? Do you say, this is a low security zone, this is a medium, this is a high? And then inside a zone, how do I then control security? So when I start looking at this and think, okay, it's low security zone, I'm happy for everything to talk to each other, well then you use a low security permit any rule that is attached to all those EPGs. When I go between zones, do I use a contract? Do I want to say, I've only got these ports open, or do I send the traffic through a firewall? So different ways that you can build it. So consider the relationships between the EPGs, and consider how you're doing security in the DC. Are you striping it, or do you want to say, for everything, well, I only want these ports open for this group, and I only want these ports open for this group, and so on and so on. We can do both models. One is more, I guess, time-consuming to do. If you automate it, it's definitely less time-consuming to do. But you need to think, where do I put firewalls? Do I want to do some DPI between tiers of the network or between different zones in the network? So that is our primer for ACI, which was 30 minutes, which hopefully was quite good. So the plan is now, what we're going to do is we're going to spin up a simulated environment. So we're going to use Postman to do this. And I'm not going to go through how Postman works and how we're going to use Runner. The whole point of this is that what we've got is a simulator, and we use sims all the time, because unless you're lucky and have got a test network and a production network and you can play around with things, then use a simulator. Start building things on the sim first of all. So we'll run Postman, and what it's going to go and do, I didn't say this at the start, sorry. What you'll get is all of these things that we're going to show you, so the Postman scripts, we're going to share all the Ansible playbooks and what have you that we've built as well. They'll all be on GitHub next week when we've put at the top of them all the Cisco disclaimer that if you try this and it goes wrong, then don't blame Steve or Russ. It's not our fault. We'll put all those, so I'll send the link in the WebEx team room, and you'll just download it from my GitHub page. But what we're going to do now is just go and configure everything that we want for our test environment. So it's as quick as going into Runner, which is just an add-on. Again, we'll go through this in a lot more detail coming up. We're going to pick the environment that we're going to use. So we've got different APIs configured. We've got our production, if you like, and this is a simulator. We're simply going to select a file, and then we'll press Run, and that's it. It's going to go and configure the network for us. All of these things, as you saw just behind, so we're going to configure the VLAN pools, we're going to configure the AEPs, the interface policies, the leaf profiles, everything like that. It's just in a spreadsheet, and it just goes and configures the network. And it's that quick. So there's really a real nice thing that you can now start doing. You can start doing versioning of your network config, because I've got my version 1 config, which is our base thing that we're going to build everything off of for part of this lab. So that could be base image version 1, and then I'll go to version 2, and then version 3, and I'll start iterating it. And what I can do with APIC is I can take snapshots of the config along the way each time, and I can just start pulling config in off of a spreadsheet. So your time to configure the network, if you would have done that pointing and clicking and thinking of naming conventions as you've gone along, then it will probably take you 15, 20 minutes, depending on how quick you are, as opposed to about 2 seconds. So we will see Postman in a lot more detail. That's the video, in case it all went wrong. But what we're going to do, first of all, is look at UCS Director. And we're going to use UCSD to configure the interfaces on that simulated network that we've just built. And the reason that we picked this was because this was from one of the TV broadcasters that I mentioned before. And what they wanted to do was give away the config of the network interfaces. So they had a team of people that go into a data center, and they just rack and stack servers. That's their job. They'll rack the server, they'll attach it to the top of rack switch, they'll do the thing on the change control process. It will go to the next team, which is the network team, to then log on and configure those interfaces. So I want to give that away. That's boring to do. Like, who wants to sit there all day configuring network interfaces? I'd rather have my feet up. So let's give that away. Now, we use UCS Director I guess one reason is it's a Cisco tool. It's got over 250 ACI tasks that come out of the box. But really what we're going to use here is the catalog that it gives you. So we're going to give very limited information or limited options that customers can select. You could call this from something else as well. So it's got a northbound API, so if you wanted to put something in front of UCS Director and push calls in that way, you could also do that. And as you saw right at the beginning, there is definitely overlap, so it can configure virtual machines, it can configure storage, but for this demo, it's not. It's just going to go and configure the network interfaces. So why do we really want to do this? And I think it's just boring, configure an interface on a switch and then go and do another one on a switch and then go and do another one on a switch. And is that a core role for the network team? Is that core to your job? And if it's not, and you can see people shaking their heads, which is always good at this point, then delegate that. Let other people do that, because it's we have this in our lab. We've got loads of switches. We've got some of our trainees, some of our apprentices that are joining our team. So I'm totally giving that job to them to do. I'm totally offloading that because it takes up too much of our time to do that sort of stuff. So let's delegate that. Now, the team that typically I would see this being delegated to would be to the server team or the infrastructure team, the team that is plugging servers into racks. And what we want to do is we want to just give 4 things. So we want to ask them to select the switch, we want to ask them to select the interface, give it a description, and then say what type of server you're attaching to it. That's all they're going to do. Everything else is predefined. So when we ran that script on Runner to start it, it configured the leaf profiles, the switch profiles, the AEPs, the VLAN pools. All of that was part of that script that we did very quickly. And what we're going to do is just configure the ports on the switches. So do you want to...
You're going to go to show this.
You want to show that first? OK.
Carry on.
This is your pre-configured bit, whilst Russ jumps on it. And through the power of PowerPoint, this is what we will do. We're just going to configure that middle layer. That's all we're going to do. And it's a very, I mentioned it before, traditional way of doing it. So on APIC, you'll see at the minute, we've got our policy group set up, but we don't have the interfaces set up. And this is the end user catalog part of UCS Director. So we'll go into the ACI tasks, and inside the ACI tasks, we're going to have this option to go and configure the network interfaces. I think you knocked up that image, didn't you, Russ? Was that one of your little icons that you knocked up as well? So what are we going to select? So the first user input is we're going to select the switches that we want to configure. Now, we could restrict this if we wanted to, but we're going to just give a couple of switches that we've got access to. We then need to go in and we need to say, what are the interfaces, what type of interfaces, as in which server. And if we look at the right-hand slide, this is attaching the policy group up to an interface. And if you do things wrong, then what it's going to do is it will error. So we can cause UCS Director to throw error conditions and say, no, you need to put context in or put the configuration in a way that we expect it. Because what you don't want is just people who do things all different ways. What's it going to say? Steve, delete me or something like that. So delete me is my pet hate that we've got. So we don't want it like this. We don't want you as a consumer to put things in the way that you would want it. So we want the interface selector and the interface ID to be in a determined way. So port 20, Ethernet 20, and then we're just going to go and press submit, and it's going to go off, and it's going to go and configure the network for us. So this is really what we're giving away. Now, the nice thing as part of this process is that we're going to insert the change ID into all of the things that we're configuring. So what you'll see as I skip through the slides is that the ID that's used to create this request is going to be posted into the interface. But what we also wanted to do, and what's a bit more advanced in this, is that we want to go and configure the interface description as well. So we want to say it's Steve's server or it's Russ's server. And the reason that's important is when you go back to your command line and you do show interface blah, you want it to say this is Steve's server. So all of this has now been taken away that we've got, and that's the SR request that's gone in as well. And if I want to undo this configuration, I can roll it back. So I can just do a rollback on the config, and it will take off the configuration. So while Russ rolls it back, I'll skip through the slides. So the other thing that that's important to understand is that this is, as I mentioned before, on a switch or pair of switches basis. So you have to select the switches that you want to do. This is just the model that we chose for this. Okay, you've got these. We've seen the demo. So what we'll look at is what happens on the fabric. So on the fabric, each time we configure an interface, I'm just going to configure a single interface at a time. It's quite boring. You could do it a different way, but for the purpose of this demo, this is what we're going to do, and this is why we've inserted the interface description. The removing is as simple as doing a rollback, and that will unwind all of that configuration that we've done. So this is really giving you control, and you will know at any one point in time who rolled out that config, what was deployed, what was the SR request that was opened, how can I go back and change this. And if we look at what happens, behind the scenes, it skipped through too many slides. Okay, so what happens behind the scenes is that we'll push in that config, we'll unwind the config, but the UCS director configuration to make this work uses a combination of generic tasks, so generic API tasks that we'll use, and tasks that come out of the box. And the reason that we've used both generic tasks and the API call that we can do is because we wanted to configure that interface description. So for those that you've been on APIC and know this in any detail, the interface description isn't part of the config that you build first of all. So you'll build the selector, but the actual description is on a second page. So as part of the script, what we're going to do is log on to UCSD. We're going to configure the access port selector, and then we'll go and get that information. We'll retrieve it so that we can configure the description as a second task. So it is very simple to do. There's only a few tasks in it. We'll do the logon. So you'll see throughout this presentation, there's lots of JSON that you'll see, and this is really where we first start getting into it. So we'll do a logon. We'll pass in the username and password. We're going to pull back the token, the access token for it. Oh, this clicker's really quick, sorry. And then this is what we're running. So we're associating the interface selector. We're pulling in that details from what the customer inputted, as in interface name, interface ID. We're going to pull that in. And that is really the extent of this play that we're doing. This is the extent of the demo. So it takes the user input, what type of server, what interface, what's the interface name, and what's the description. They're the only 4 inputs that we're going to give. And then it goes off and configures the network. Now, this whole session is about automating ACI, and we've automated it, but really in a very basic way, you could argue, because we've not actually delved under the covers, and we've not learned anything more about how the models work behind the scenes. But this gets you going. This is definitely a starting point, and the consumers of this tool, of this catalog item, it's great for them, because that's all they care about. Put in 4 parameters, go and configure the network, job done. So this is ideal for that type of scenario. But to really get the most out of automation, you do need to understand how automation works. So to this point, hopefully, for most people, it's been quite high level. So now we'll start going under the covers a bit. So the policy model itself, and I just picked this out of the documentation, so you can go to the link if you want and read it. All the policy model is how the objects are related to each other. So I've got an EPG, that's bound to a BD, that's bound to a VRF, that lives inside a tenant. So it's all these relationships that we've got between the objects. And when you start learning them, you can turn on, at the top right, you can show debug info, and at the bottom of your screen in tiny, tiny little letters, it will tell you the current object that you're looking at. So that's the first thing that you can do. And the model itself is this. So at the root, if you like, I've got my controllers, I've got my tenants, I've got the inventory that I've got, so the fabric setup, the VMM domains. And if you were to look at the GUI, these are effectively your top tabs that you've got around it. I've got my tenant tab, I've got my access policies tab, I've got my AAA tab, and so on and so on. So they're the policies that we're going to affect. And then in each side one of those, I've got all of these objects, all of these different objects that can be related to each other. And when you're using the GUI, you're actually learning this anyway, because you'll know that when I configure an EPG, I'll bind it to a BD, and that's the binding that you're doing. So you definitely don't need to know every object, but the more familiar you are with the GUI, certainly, the easier this will become to understand as we go through. Now, these objects, you can access them in different ways, or you can call them in different ways. So I could call a type of an object. So I could say, call the type of object for an EPG, and it will go and give you a list back of all of the EPGs that I've got configured. Or I could say, go and give me the config for Steve's tenant, and it will go and get all the config for my tenant. So there's two different ways, which is quite important to understand. One is by calling the object itself by name, and one is by calling the type of object that I'm interested in. I could call a type of object for an interface, and it will give me all of the interfaces. Or I could call the specific interface on switch 1, and it will give me just that interface back. So two different ways. And the way that we get this information, or we manipulate this information, is that we do posts, and we do gets, and we can do deletes. The delete itself is one that I've never, ever used, because as part of the content that we push in, we can say, create this content, modify this content, delete this content. So typically, you wouldn't use the delete option, just post and get. They're the two that you'll use. So this is just going to give you a representation of how these objects look. So if I wanted to do a call, if I wanted to go and call an object, if I call the distinguished name, that's actually the name of the object as it lives inside this big tree or this big database that I'm building. Or I could just go and say, call FV tenant for tenants, or FVBD for bridge domains, or AEPGs for EPGs. And there's a huge list of these, like there is a huge list of all these different options that you've got. So, how do you learn this? How do you start learning how all these objects work and how you start putting them together? Well, you could read the documentation. That's always a good starting point, unless you're me, because I hate reading documentation. It's like, it just bores me. So I always kind of get on and start playing with things and how do I actually make this work? And the way that I do this, there's an inbuilt tool, which is called Visori. So this is the API browser. So this is going to let you put in queries. So that on the left-hand side, we can put in a query, and I could query for FV tenant equals Cisco Live, and it will go and pull back the config for me. So you can use the API browser. And I use this all the time. And you can use Postman in conjunction with it. Because what you'll start doing is learning that you'll kind of do some stuff in that GUI on the left, and actually that's a bit time-consuming, so then you'll start using Postman. And we'll see Postman in all of these slides coming forward, but all it's going to do is log on and get information from the system or push information back into the system. Now, we'll use queries. I use queries all the time, and there's a bunch of different queries that so this is just a placeholder on the right-hand side, just to zoom in and give you an idea. But I could query a target, I could query a subclass or a class of objects that I've got. I could sort the output by like ascending order or something like that. So I can manipulate all of the different objects or what I'm pulling out of the system in different ways. So I have this as my template and you'll get all of these calls that we're going to be showing you. So I have a template set so that I can then just start putting in values and thinking, okay, I'm going to query FV tenant and see what I get back, and then I'll query for a subclass and see what I get back. So I have a template that I start from, and then I build everything off of that template. Now, when I start pulling this information back, if you consider this tree model that's being built, this relationship between objects, what I can do is I can pull back a specific object. So I will pull back one object, and in this case, I pull back, if you can see it on the bottom of the screen, the tenant is common, and the BD is subnet 10. So I always call my bridge domains after the subnet. So it's BD 192.168.10. And I'm just going to query that object, and it's going to pull back the configuration. Now, on this configuration, a lot of things I'm not really interested in, but other things I will be interested in, and we'll see this as we go through the demos of how we're going to start automating it. The next thing that I could do, though, is that I could query the children. So I could say, what are the children of this object? Who's related to me? And pull back that configuration. And in this case, if I go back one slide, at the top where it says total count, that's one object that I've pulled back. When I've queried the children, I've got lots more objects. So I've got the subnets, for example, the layer 3 outs. So I'm going to pull back lots more objects. If I do the subtree, then I'm going to pull back loads of objects. And what this is giving me is a list of each object that I'm going to pull back from the tree. So just the top one, the next tier down, or all the objects. And you might think that's great. Okay, I've got all these objects, and then I can go and take them and change the config and post it back in. But you'd be wrong, because it's not in a tree structure. So what we can do is that we can add, or we can append to the query. I can do response, subtree, full, and then it will structure the output that comes back. So now I can change things in this, and I can start pushing things back in through the API. So that's the quick intro. Now, I did a Meet the Engineer session yesterday, and I said, oh, there's a quiz for the audience. And I showed them the quiz, and I can't actually see if the customer's in the room. So if she is, you might know the answer. Oh, yes. So you should know the answers to the quiz. So there's 3 questions for you. And this is a bit unfair, because we're just into the session. But the quiz time is, I'm going to put up 3 queries, and then it's like, if you can answer the question, then we'll think of a prize. And I'm almost hoping that you don't get it, because we haven't got the prizes yet. But we've got ACI books. You'll have the ACI books. I'll send them over to you. So these are the 3 queries that I'm going to do. And I've just taken these from Postman by discovering what I wanted to pull out from the network. So I'm only going to give you 30 seconds. So does anyone want to hazard a guess at what the first query is going to go and do? Or is it going to be silence because there's so many people in the room? Any takers for the first one? Oh, somebody shouted, or somebody left, one of the 2. So the first one is I'm going to go and query the EPGs. So the class at the first bit is AEPG. So it's going to go and query the EPGs. And then what it's going to say is, tell me the EPGs that are associated with a subnet. And the subnet is 10.52.249.96. Now, if you were to do this in the GUI and point and click around, you would sit there for quite some time and probably miss something. So this is the first reason why the API is a fantastic thing to use. So this will go and tell me all the EPGs that's on a subnet. The second one is going to go and tell me the relationship between FVBD, so bridge domain, and the external layer 3 interface, the layer 3 out, that I've called, cunningly, OSPF to external VRF global, because that's what it's called in our lab. So it's going to go and pull back all of the BDs that have got an external routed connection. And the last one is one that I use like all the time, which is go and tell me all of the interfaces where I've got VLAN 8 configured. Because for those of you that go and do a static binding on an EPG, and it will say VLAN already in use, and you're like, okay, well, where's that in use? Which tenant, where does it live? What's the tenant? So now what I'm going to go do is I'm going to go and query all of the interfaces in the whole system looking for an NCAP of VLAN 8. So this is really the power of using the API. This is why you should really start investing the time into learning how it is. And both of our GitHub links are at the bottom, so there's some stuff already up there. There'll be some UCSD stuff. I'll post up the playbooks as well, so you'll have all of this information for you. Okay, so the next use case that we've got is that we're going to use, we've seen it already almost, is that we're going to use Postman and Runner to go and configure all of the subnets in our system. And I think this is a core thing for a network team. This is definitely a core networking job, running the subnets, configuring the routing, and all the rest of it. And we use Postman because it's dead easy, it's free, it's simple to use. I can query stuff, I can manipulate things, I can push the config back in. You do need to know some JSON or XML. All the examples that you'll see in this deck are all in JSON, but you could equally do them in XML as well. Just to start building this, what we need to do is, first of all, build the config in the GUI. So dead easy, I'll go in and I'll go and create the objects that I'm interested in. So I'm going to go and configure subnets or bridge domains. Then I'm going to go and save the configuration, and that's going to give me a mess. So this is going to be all of my JSON just dumped like that in front of me, and I'm going to look at it and say, yeah, okay, that's useful. That's not really helping me too much. So the first thing that I'm then going to do is prettify it. So I'm going to just put it through prettify that I've got in Atom, and then it's going to give me a nice structured list of the JSON for the bridge domains, for the EPGs, for every object that I'm going to pull back from the system. And then you need to understand the code. You need to understand what that is that you've just pulled back. And by understand, all I mean is you need to think, well, I just configured something called my subnet, my BD, whatever you've called it, and then you need to look at that and think, okay, well, where is this in this big output of text that I've got? So if we look at the first part on the left, I'm going to see my application, so my app profile, and then I'll see I've got children. And you know, if you've configured this in the GUI, that I've got my app profile, and I've got the EPGs that sit below that. And then below the EPGs, which is in the middle, it's also got children. So a child of an EPG would be the contracts that it's providing. So it's going to provide and consume contracts. It's going to have a binding, so a static binding or VMM domain binding. It's going to be bound to a subnet. So they're children of this. Now, I don't need to know, and honestly, I don't know every object that will be up there. I'm interested in the things that I want to configure. I want to change the name of the EPG, the app profile. I want to change the subnet that it's attached to. So just look at the things that you're interested in. Kind of ignore the noise that's going on around it and just pick the content that you want. The next thing we're going to do is we're going to make an environment in Postman, and this is dead easy. Download Postman, make yourself an environment, and we will have lots configured, as you'll see when we go through the different parts of this session. And this is just going to allow you to log on and start sending data. So we'll have an environment for UCS, so UCS system. I've got it for a couple of different APIs that we've got in our lab. And we're going to include the password. And once I've got this set up, 10 minutes to set this up, I can then take the config that I downloaded. So I'll take that output, and all I've done is I then modify it. So I give it a new tenant name, for example, and then I can post this back in. So you need to, inside Postman, you go to the body, you just paste your JSON back in there, press post, and it will be done. So that's going to configure a single object for me, which is great. But what if I want to do loads of objects? And in the demo that we saw, we configured VLAN pools, we configured APGs, we configured loads of things. So we can use Runner to do this. And Runner's just a part of it. And what you've got here, though, is that I'm going to take the parameters that I'm interested in and make them variables. So I will call the tenant tn_name as the variable name. I will call the EPG EPG_name. Is that what I called it on here? I will give everything a name that is related to me that I'm going to use as a variable. And there's a really important field, which is the status is field. And the status is tells you whether or not you're going to configure the object, or whether you're going to modify the object, or whether you're going to delete the object. And this is where we can start making these changes very fast. So these are all my variables. I've put my variables into the file. And my file is either going to be in a spreadsheet, or it's going to be just a JSON list of variables. I'm just going to stick it in a CSV file. And then what I'm going to do is create a post. And the post has taken those variables that I used, and it's now inserted in there. And so what's going to happen is that every time I call for an object of name, tn_name, it will take it from my list in my variable file, and it will insert it in. And the same for the BDs, and the same for every object that you want. So this is your very quick way of getting started. So in this case, we're going to configure the subnets, the layer 3 outs, whether it's a public or private network, only the things that I'm interested in. So all of those other objects, don't care, let those go. And then what we'll do is we'll put it through Runner. So we'll select the environment, we'll select that CSV that we've almost seen already, and then we'll just press play, and it will go and configure it all, as if by magic. Now, if I wanted to delete this, on the right-hand side where I've got my created modified, all I need to do is change that field to be deleted, and it will go and delete all those objects. So very easy, a very quick and simple way to get up and running using JSON. Have you got a delete one, Russ, as well?
Just a sec.
Oh, got a deleted one as well. So we almost rehearsed this, as you can tell. So we'll run the deleted, and it's just going to remove that configuration. So it gives you almost a wind forward and wind back option that we've got here. But it really is your, I guess, starting point to now start understanding API calls, understanding the config, understanding how we can do things. And it's a good way to get up and running. OK, we've seen the BDs before. We don't need the video because it worked. OK, so we've looked at UCS Director. And we've looked at Postman as the two options that we've got. to start configuring the network. And they're both pretty easy. I'm guessing most people have used Postman, hopefully, that's in the room. Use case 3 is probably a bit more complex, but a bit more interesting. We're going to start using Ansible now to configure the network and to pull details out of the network. Now, the way that we're going to use Ansible as part of this demo is that we're going to use it to configure the access lists, or the contracts that we've got inside the network. Now, we're going to take user input for the demos that we'll show you. Really, with Ansible, it's an engine, it's a tool that goes and does the things, and you would input in a different manner. So you would use Tower, so use a GUI to push the inputs, or you would front it with ServiceNow or whichever tool that you want. What we're going to do is we'll actually put the user input in, so we'll type things in. But in a real world, you would front it with something else. But it's going to show you really the power of things that we can do to make it very simple. So is access list configuration, is contract configuration core to the networking team? Now, lots of you will probably say yes, because it's what you do. It's just, if you're networking security, that's typically what you'll do day in, day out. However, the contract configuration is really something that the application teams want. So just let them configure it. Now, normally when I say customers, let the teams configure their own access lists, they normally say, well, they don't know what they want working. They'll just open all the ports. I'm like, yeah, okay. I don't care if they open all the ports to their application, because it's about ownership and responsibility. And right at the beginning, when we looked at that DevOps and legacy, if you like, way of doing things, in the DevOps world, you almost want to give responsibility to the application owners. If they open the wrong port, that's what they've opened. They've made that choice. No different than them saying, open this port, you open it, and it was the wrong port to open. So just let them do it. But it is a big shift for lots of customers to think, actually, why not let the team that wants the applications to run to configure the ports that are open to their applications? And I definitely get pushback, it is fair to say, from customers when I speak to the network teams or security teams about this. When I speak to the CTOs, they're like, absolutely, that's exactly what I want to do. I don't want the network team wasting their time doing firewall changes. Now, one of the customers is here, because I sit there about 5 rows back, and I asked them the other week, I said, how many firewall changes do you have? I said, about 100 a week. And I asked another customer yesterday, if I'm right, and they said it's 6 weeks to get a firewall change done. 6 weeks to sit there and wait for the firewall to be updated and ready to... Why? I'm just like, that's just crazy. Let them configure their own rules. Give them some gating, gates. They can only configure these rules. They have to be approved by whoever, so it goes through a change control process. But actually don't have people that sit there and say, okay, it's Sunday night, it's overtime time, I'm going to go and configure the network, I'm going to configure the firewall changes. Just let people configure them when they want to configure them. Because that's what they'll do in a cloud. If you go to a cloud, you will just configure the network or configure the access rules exactly when you want them. There won't be any sitting there waiting for somebody else to do it. You make the choice, you automate it, it's done. So if you change the way that you work internally, you can actually provide the same functionality to the consumers of the network. And they'll definitely start using that. Now, contracts themselves are very similar to access lists. They are access lists under the cover, or firewall entries. And as you all know, there's a consumer and a provider for the contract. And in this example, all I'm going to do is I'm going to put a contract in place that says permit to port group 2. So port group 2 is the provider, port group 1 is the consumer, and I've got connectivity between them. And under here, I'm going to specify the ports that are open. Now, I've got a whole set of slides on exactly how these work under the covers, how the access lists are built, how we do the security, how we do reverse ports, how we do single direction, reverse direction. There's not enough time to go through this. So if you want those slides, just drop me a question in the WebEx team room, and I'll drop you the slides. There's about eight or 10 of them. And I go into all the command line, how you do show access list effectively and actually pull back that information. So all of that is covered. What is very important to understand with this provider and consumer is that if I provide a connection or provide a port 80, so my server on the right, number 2, he's going to provide a service running on port 80. That means I can connect from any port, if I've specified any as the source, to port 80. It also means that if I set port 80 as the source port, I can connect out. It's just an access list that gets configured. So again, I configure any source to port 80. Great, I can talk to port 80. I can also connect from 80 going outbound. I can't connect out from port 81 or 82 or 83, only from 80, because that's the one that's specified. So as I say, I've got a whole section of slides out of a different presentation that I do on how access lists work and how the contracts work under the covers. So if you want them, just ask for them. Now, the components that make up the contract itself, there are lots of parts to this. What's important is that we set some naming standards. So as you'll see at the top, my contracts are going to be named permit to, app profile, EPG. So in the name of my contract, it will tell me the app and the EPG that it's going to be associated with. The subject, in this example that we'll see, is just going to be TCP or UDP. So what type of protocol do I want to allow to be used as part of the contract? And then the filter and the entry are the ports that I want open. So I'm going to say, what's the destination port? So therefore, my filter name is going to be TCP, source, any, to destination, TCP, and then the port number. So that's fixed. So every time I run the automation job, the filter itself is going to have a fixed description based on what I've told it, what the input that I've given. So if I want it to port 80, it's going to be, permit to source destination TCP port 80. So it's very fixed and a very controlled way of configuring this. The nice thing about this is that when you look in your UI and you look at all of your filters that you've got configured, all of them will say TCP at the start, so you know what it is. And then it will say the source port and then the destination port. So you can read down your list. Now, you can do things that you could have multiple filters on a subject, multiple entries under a filter. There's all different ways you can build it. Ours is going to be very, very fixed. And the reason that we want it fixed is so that we want it consistent and that we can just make it a repeatable task. Now, where should we place them? So we've seen this already a few slides ago. So we're going to place our filters up in the common tenant, and then we're going to go and create contracts inside the Cisco Live tenant, he says, with fingers crossed. So this is the model that we're using. Now, prior to this presentation, when I say prior, like this morning, when we sat outside having the panic before we come on stage and start doing stuff, we deployed a new WordPress app into the lab. WordPress itself is very, very simple. I've got a VRF, I've got 2 subnets. One is external in Cisco world, as in it's a 1052 network. That means we can talk to it from corporate. And the other is a 192.168, which means I can't route to it. That's private to our lab. We've built an app profile, Cisco Live 19, and then I've got my 2 EPGs, so my web server, my database server, that are using 2 port groups inside ESX, and then I've got some servers deployed. But our app doesn't work. Hopefully it still doesn't work. And when we actually look at this, what we'll see is that I'm getting an error. And so the error is it can't establish a connection with the database. And if I actually connect onto the database server, we'll see at the bottom of the screen that it's listening on port 3306. That's the port that I want to connect to, but it can't connect. So web server can't talk to database server. Now, it's pretty obvious that I've broken something. There's no contracts in place, or there's something wrong on the network. But how do I go about understanding what's happening? So we've got a couple of playbooks that's going to help us diagnose and, in theory, fix the problem that we've got. So the first playbook that we're going to look at is actually going to look at the IP addresses that live inside those EPGs. Now, Russ, do you want to run the 1-to-120 first?
Yeah.
So because I know the reason that it's broken, we'll run it against a different IP address. So what we're going to do is we're going to run a playbook. And at the top, And don't worry, I'm going to go into how you run the playbooks and how you configure them. I'm going to run a playbook that's called get host ACI details, and it's going to go off, and it's going to go in query, or not in that case.
If I could type.
If you could type. 1052, 249, 120. OK, it's a bit better. So this is doing loads of stuff, and you'll get the playbook that does all of this stuff. But what's important is the stuff that's there in green. So it's going to pull back all of the IP addresses that's in the EPG. And if you just scroll up slightly, Russ, it's going to pull back as well all of the contracts that I've got in place. So I've made a query to APIC and said, OK, this is the IP address. What contracts are provided? What contracts are consumed? What's the IP addresses in them? And the reason that we're querying this is so that when we put the contract in place, we know what else we're going to affect. Because in this case, in the case that we'll do, there's only a single server in there. But if I was to apply changes here, those changes will relate to all the other IPs that's in that EPG. Sorry, so many acronyms. So this is the first one. And if you run this now against the DB server, OK, so when we query the DB server, loads of output, what we'll see is that there's no contracts in place. So the two brackets that you've got with nothing in between. So the output says, I've got no contract. So it's pretty obvious now why I can't connect from my web tier down to my database. There's no contract in place. Now, you could have looked at the GUI. We've just done it through a playbook just to actually show you how that works. And sure enough, if you go into the contracts, we'll see no contract. The one that you can see there, the permit to CCC, just so that there's no confusion. Because we're using Cloud Center to deploy this, which comes next after Ansible, we have to have a contract that lets us talk back to our Cloud Center deployment, or our Cloud Center environment, rather. So that's why we've got a single contract. But there's no contract in place that allows us to talk from web server to app server. So what we'd like to do is put a contract in place. Now, I could go on the GUI, I could configure my filters, I could configure the contracts, the scope of the contracts, everything else, but that's just time-consuming. So what I'm going to do is run a playbook that's going to go ahead and do this for me. So we'll look at common tenant. If you just look at the filters first. OK, so we've got no filters configured, the contracts aren't there, etc. So the inputs that I'm going to take for this. Now, mentioned before, in real world, you'd have Ansible Tower or ServiceNow or something in front. But what we're going to do is we're going to put in the source and destination IP address. So what's the source IP? It's my web server. What's the destination IP? It's the database. What protocol do I want to use? So I'm going to use TCP. That's what I'm going to use. And what port do I want open? 3306. And that's it. That's all the information I need to give to go and configure the network. So that's going to go and configure, it's going to go and create the filters, it's going to create the contracts, it's going to create the subjects, it's going to take all of the naming from what I've told it. But hang on, I only told it the IP addresses. I didn't tell it any EPG names, any tenant names, or anything like that. So what it actually does is it goes in, looks at the IPs, says, oh, that IP is part of this EPG, that's part of this app, that's part of this tenant. And I'll take those out, I'll extract those out of the gets that I'm doing, and I'll go and use those elsewhere in the playbook. So when I start pushing the information back in, it's going to construct the naming convention that I've used. So I've hard-coded it. But if you think now of your consumers of the application, or the application owners, rather, all they're interested in is the source and destination IP address, and they're interested in the port that's open to it. So that's why that's all we've given them. They certainly aren't going to know what an EPG is. They're not going to know what a tenant is, what a contract is, what a subject is, what reverse ports mean, or anything like that. So we've given them the very basic information: source IP, destination IP, is it TCP or UDP, and what port? And that's it. So if you put that in a nice GUI front end, that's their control. That's what you then give them. And if you're going to get them, so if we go and get them now, we'll go and do the get, so the same thing that we did before. And sure enough, now you'll see that I've now created. And if you look at the naming convention that we've used there, so the name is permit to app profile and dserver1. And then the filter is going to be TCP, source, blah, and that's going to be configured, as you can see, in the UI. So all of that has been set. Now, you could give loads of options. All of these things could be variables that you allow to be inputted into the system. But what we're going to do is we're going to fix as much as possible and give as little wiggle room as possible for error. So if they were to put in the wrong port, for example, then they've opened the wrong port. OK, we could run the delete playbook and actually remove that as well. You know, all we're doing is giving them control of their actual applications. There you go. And there you go. There's the contract and filters that's been created. So this hopefully is just giving you an idea of how you can use a playbook to actually do this. And sure enough, our WordPress app says hello world, because what else would you, well, it could say hello Cisco Live. So now our app is now up and running without going onto the GUI, without doing anything other than source IP, dest IP, TCP or UDP, and which port. That's it. That's how simple it is to actually configure the network. Do you want to do this now or do it afterwards? We'll do it afterwards. We'll come back to the SSH one in a second.
Okay.
So, that's the videos. We don't need them. OK. So how did we start writing this? So the first thing that we needed to do is that we needed, well, a can of Red Bull, a cup of coffee. So we needed to get the minimum information that we want. If you give people loads of things that they can import, generally, they'll just make mistakes. So we've given them very little input that we need to make this work. We need the source, destination IPs, the protocol type, and the port. That's all we're interested in. We then use Postman, and that's why you'll get so many Postman examples to get the required API calls to make this work. Then we'll define a list of tasks, list of things that we want to go and do. Now, inside Ansible, there's lots of tasks or roles that are already there for you. But where there's one that doesn't do what you want to do, and in our case, there's not everything that we want, we're going to use the ACI REST module. So we're going to use that one, and we can post in directly into the API. We're going to post in calls. Then we need to start writing the playbook. Then you'll hate YAML. So the playbook's written in YAML, and it uses an indentation method. If you think of JSON, where you've got braces and brackets, YAML rather uses indentation, so spaces. I think it's fair to say it drives us both crazy when we're writing these. So then I convert it to JSON and convert it back to YAML and do all sorts of things. You'll get the hang of it. It's not overly hard. It's supposed to be easy. Then we'll start writing the plays, and then we're going to merge the plays into a playbook. Now, when you look at the playbook that I'll go through, you could absolutely write it in a lot more condensed, streamlined way than I've done it. And the reason it's done in the way that I've done it here is that it's to help you understand what's in it. And we were chatting with one of the guys yesterday, and he's like, well, you should have used Ansible anchors, and you should have done this, and you should have done this. So it's not how you might do it. It's an example to help you get going with Ansible. So if we start filling in the blanks. So Ansible itself, it is pretty easy to use. It's agentless, it's open source, it runs on your Mac, it runs on a Linux server. You can configure loads of different things. We're going to configure ACI. There's modules for iOS, NXOS, iOS XR, for anything that you would possibly want to configure, be it network or server. There's probably a module already out there. Now, why did we use it? Well, it's the latest thing, isn't it? It's the thing that everyone is interested in. If you speak to people in your dev teams, I would be quite confident you'll have Ansible running somewhere, or they'll be doing something with Ansible. You don't really need to know lots to get working. So the modules we give you will help you get going. It definitely won't be everything that you want to do. You'll use the ACI REST one, but it's enough definitely to get you going. You do, you do need to have some knowledge of JSON, because that's what we're going to use when we do the ACI REST ones. Now, the components that make it up, we've got a control machine, so we're going to use the control machine. It's actually going to run on a server that we've got in our lab. The target, so the thing that we want to go and configure, is obviously going to be APIC. We're going to pull in some files. So when you saw before, Russ was doing -e and then APIC credentials. So we're going to pull in variables into the playbook, and we're going to use those as part of the configuration. So it's very simple to get going. Now, I mentioned before there's lots of modules. If you just load it on your laptops, do Ansible doc -l, look for ACI, there's already 60 plus modules. And the request yesterday from one of the TMEs was that if we don't have a module for something that you want, then just please raise a request on GitHub and we can write a module for you. We've got a guy that's his job. I couldn't do that job. That's his job, is to write Ansible modules. That's what he does day in, day out. Now, when we started writing these playbooks, I went back to Postman and to Visori because I know what I wanted to do. So the first thing that I wanted to do was that I wanted to go and get information from the system. So I'm going to take that IP address and I'm going to go and get data back from the system that's going to tell me what's the EPG, what's the app profile, et cetera, et cetera. So using Postman is great because now it's giving me stuff and it's going to help me structure it. And you'll see it's not expanded on the screen actually. But there's in the contract demo folder, you'll see lots and lots of different calls that we've done to pull back the data and to structure the data in the way that we want it. So all of these queries, in this example here, what I'm going to do is, and it'll be very small for you on the screen, but I'm going to go and query for an IP address, and the variable that I'm going to give is the endpoint IP address. Now, when I'm testing this, I can actually, in the environment, in the Postman environment, I can actually put these in as variables. So I can actually call this, just as we saw with the Excel example, I can start pulling details into Postman as the variables that then actually, when I go to Ansible as the playbook, I'm going to use exactly the same method. So if everyone's sitting comfortably, we'll have a look at the playbook itself. So first thing is the playbook itself, just a very quick breakdown, then we'll get into it. Mentioned before, it's all indentation, so you need to know how you're doing your indentation. And at the top, we're going to do 3 dashes to start it. We're going to have the host that we're going to run it against, the host, we're going to have the target, and we're going to have a bunch of tasks that we're going to do. So what I'm going to do is I'm going to step you through all the different tasks and all different plays that make up this playbook. And then by all means, take it, change it, rip it off, do whatever you want with it. First thing that we're going to do is I'm going to set the scope of the contract, So I'm going to say the scope of the contract is context. So that means it's valid within the VRF. That's the first thing. You don't get a choice. So when you use this playbook, because this is how I built it, you don't get a choice of the scope of the contract. It's always set to VRF. I could change that to be app profile. I could change it to be global. I could make that an input that you give as well. That's also an option. Keep it simple. The scope that I've set is context. The next thing that I'm going to do is prompt the user to enter some details. So they're going to enter exactly what we saw. So the vars prompt, they're going to enter the source IP address, destination IP, subnet name, and the destination port. Then what I'm going to do is I'm going to do a thing called set fact. And the set fact is basically going to take that inputted data, and the fact lets me use it elsewhere in the playbook. So it's just a bit like a variable, but now it's a variable that is available across all the plays that I'm going to have in a playbook. And in this particular example, we've got 9, 10. If you look at the tabs along the top, there's 10 different plays in this playbook. It could have just been done as one massive play. Again, the choice that we made when we built it was to separate it into individual ones to A, make it easy to debug, hopefully, and B, so that when you look at it, you can say, okay, well, that does this, this does this, this does this. So hopefully it'll be simple for them to use. So I've got my source IP address, I've got my destination IP address, and if you look at the bottom, the filter name, so this is the filter name that gets pushed into APIC, it's going to take the subject name, and that's the input, so that'll be TCP or UDP. It's going to then say it's fixed, source port, any to des port, and then it will take the destination port that you put in as the input. So that's how we're fixing the name of the filters that we're creating. So, first real thing that we do is that we're going to take a snapshot of the system. We're going to take a snapshot of APIC, so we've got the current config. And this is an inbuilt task, if you like. This is an Ansible module. So the ACI config snapshot is there, runs a snapshot. That's my starting point. The next thing that I'm going to do this is where it gets a bit more interesting, is that I'm going to go and take the information that I was given, the source and destination IP addresses, and I'm going to go and look on the network and find out where these are. So the key thing is that API path that you see, I hold my hands up, I did not write this. I didn't sit there and think, okay, so the path is API / I need to read it, no / whatever, whatever, whatever. The way that I got that path was that I used Postman. So I used Postman to go and query APIC, pull back the information, and then I'm going to use that path, that API query, inside Ansible. So it helps you start with Ansible. And then what I'm going to pass in is I'm going to do the query. Right at the end, you'll see I'm going to push in source IP address, and that's the IP address that was entered when you actually started the module. Okay. I'm then going to go and split out the information. So I'm going to extract from the data that I pulled back. I'm going to pull back the tenant name, the app profile name, and the EPG name, and I'm basically going to pull those apart. I'm going to get rid of the slashes. I'm going to get rid of the TN dash and the AP dash, and I'm going to be left inside itself with tenant, app profile, EPG. And then I'm going to, you see at the bottom, I've got a debug message. I can actually output that as well. So when I run the debug, I can actually say, this is the tenant name, this is the app profile name, this is the EPG name. Then I'm going to do the same thing for the destination IP. So won't need to go through that. And now I've got the variables for my source and destination IP addresses. I've got the EPGs that I've got, the app profiles and the tenants. I'm now going to make the filter. So I'm going to take that variable that I set at the front with the set fact. I'm going to insert the port at the end, and that's going to go and create that filter for me. And then I'm going to create the filter entry. So I'm going to actually add the entry underneath the filter, and I said before that's a one-to-one mapping. Then once I've done that, I'm going to make the contract. And now what it's going to do, if I look at the API call that I'm using, I'm going to insert in there the provided tenant name. So the destination IP is obviously the provider, because that's what I'm talking to. So that's the provider tenant name, provider app name, and provider EPG name. So I'm going to push that information in. That's how I'm going to build the contract itself. And then if you look at the bottom, the name is going to be permit to prov app name, prov EPG name. Once I've done that, I'm then going to add the subject and the filter to it. So again, I'm going to use those same variables, and I'm going to push those back into the system. And then the last thing that I'm going to do is that I'm going to bind everything together. So now I've created my contract, I've got my subject, I've got my filters, I've done all the hard lifting. All I need to do now is to go and put the contracts onto the EPGs. So as you'll see there, this is another inbuilt module for Ansible. So the ACI EPG contract is one that we give you. So I don't need to know any API stuff. All I need to know is the username, the password, what's the tenant, what's the EPG, what's the app profile, the EPG, and the contract. That's all I need to know. So this is an inbuilt one. So you apply it to the provider side. We apply it to this consumer side. And that's it. It's configured. There's nothing else I need to do to make that work. Now, I mentioned right at the beginning that when our app was deployed, we used Cisco IP space, as in 1052, and 192.168. So the problem with that is that I can't get from our laptop, Russ won't be able to get to the database server directly. He won't be able to SSH to it. So he needs to jump. He's going to jump onto the web server side and then attach from the web server onto the database server, so just an SSH between them. But that don't work. That doesn't work because we didn't open SSH. So there's no contract that allows us to go with SSH from the provider and consumer. There's no contracts in place between them. So if I want to add a new port open, if I want to open a new port to my database server, it's going to be as exciting as we saw before. So source IP address, destination IP address, TCP or UDP, and then the port that's open. Okay, so you've got another half an hour in this session before everyone gets up and goes, okay, they're clapping, we've got to go now. So we're just going to open port 22, and it's as simple as you saw the first time. That's it. I've now got port 22 being opened between those two IP addresses. Forget everything about EPGs and app profiles and tenants, because the consumer, the person that owns the application, that they don't know about those things. So don't ask them to understand stuff they're not interested in. You're going to do a query? So when we do a query now, you'll see I've now got another contract. And hopefully by the contract name, you can see very, very clearly what that contract is going to do, because it's going to permit TCP from any to port 22. So it's a very simple way of doing it. Yeah, and as if by magic, I can now SSH between them. So we are on the home stretch. So we've looked at UCS Director, we've looked at Postman, we've had a look at Ansible, and the last one is going to be the shortest one, and I'm actually ahead of time, which is quite good for me. Okay, we're going to use Cloud Center to go and configure the network, and we use Cloud Center to deploy the applications. Now, there might even be, because we've got 30 minutes left, time to actually see the whole thing work. I'll do some padding at the end. When we deploy this application, what we're going to do is we are going to have configured the network. So as network people, we've configured the bridge domain, and we've configured the associated default gateway. We've attached it to the layer 3 out. We've done that. There was definitely 30 minutes left. We've attached all of that. We've done all that configuration ahead of time. And then what we've done is we're going to act like a cloud provider. And we're just going to go, that's it. My job's done. It's Feet Up Friday. I will totally be on the beers tonight. So I'm just going to sit there and let the application people do exactly what they want to do. So the app person is going to deploy an application. We'll do a WordPress app again. They will choose what ports they want open. So they're going to choose the consumer and provider ports that they want to have open between them. They'll choose the type of machine that wants to be deployed. So it's going to deploy some VMs. They're going to be, I think, one's a Red Hat, one's Ubuntu, isn't it? So we're going to deploy some different VMs that we've got onto the network. All the ports will be open automatically. Network guy is just sat there and gone, OK, you've got your subnet, just do what you want. This is where I think network team should be, which is now the network really is just a consumable resource. And everything that is being configured on top of the network is configured through some abstracted tool. You don't have somebody going on to AP configuring contracts and filters and filter entries and everything. You don't have them building EPGs and app profiles and all of that. What you have is that all abstracted away, and you just offer IP space inside a tenant. So you build your Cloud Center tenant, or your Cisco Live tenant, as will be, and in there, people can do whatever they want on the system. So we use Cloud Center because it lets you do that. Now, there are clearly other tools on the market, like we say on a disclaimer. So it's not just Cloud Center. There's lots of tools that you could use to actually provide this model of work in this way that we can actually do network as a service, but there's already a NAS. But we can offer the network as just a platform that you can come along and use. And it does allow the application team to be self-sufficient, because you don't need them coming to you and saying, can you open a port for me? Or they're racking a server. If we've front-ended the server config with UCSD, they can rack their own server, they can configure their own ports, they'll use subnets that you've configured as networking teams, they'll then deploy their applications on top of the network. And through Cloud Center, we can do network config and we can do application config as well. So we could stream in data into the application, we could patch it, we could do updates to it. As part of this demo, we're not going to do all of the other things that you can do with Cloud Center. We're going to be very specific to an ACI programmability demo. So first thing that we're going to do is that we're going to go into Cloud Center, and I'm going to go and deploy my WordPress application. And if I look at it, if I modify the application, what you'll see is that I'm going to choose how I want this application. So I'll click onto the next slide, otherwise we'll be quite out of sync. So I've got my web server tier and my database server tier. And what I'm going to look at is the firewall rules that I've got between them. So firewall rules will make sense to an application person. ACI speak, this is going to do the contract for us. So just as we saw before, I just entered a port number, very similar. All I'm going to do is say which ports do I want open from my between my database server and my web server. So this is always the provided side. So I'm providing port 3306 and port 22 up to my web server tier. If you just click on the web server tier, it should be, I think, 18443. So if I look at my web tier, I'm providing a contract outbound that's going to be consumed by something else, like a layer 3 out, for example. So they're the firewall rules that I'm going to create on the system. And there's a cunning box, if you can find the box. There you go. So this cunningly named box of inter-tier communication firewall rules. Okay, so what this is going to let us do is configure the rules between our EPGs on the network. So this is going to set up the EPGs. It's going to effectively build all the app profiles and configure everything for us. So once I go on to deploy my application, if I scroll forward a couple of slides and catch up, all I need to do is give it some information. So I need to give it, obviously, clearly a name. You're going to call it Steve's app, Steve's WordPress. OK. So we're going to give it a name. We're going to go and tell it where it's going to go and be configured. We're going to give it, we've already given it the details. We're going to tell it which virtual switch, in this example, it's running on. And then we're going to say, OK, this runs on VMware. We're going to do a link clone. There you go, in the lab. This is the vSwitch that we can select. This is the tenant where we're going to deploy it to. This is the external connection. And then we're going to say, OK, make me some new EPGs. So these are the EPGs that I'm going to create. And this bit, just pause 1 second, Russ, this is why I name my bridge domains with the IP subnet that's associated. Because in the list, all Russ saw was IP subnets. If I named it Steve's bridge domain, that means nothing to an application person. So that's why I name it that way. It's just the way that I do things. So we're going to select it. We're going to tell it which cluster it's going to deploy on. And then when we start deploying this application, it's going to go and build everything for us. So it's going to deploy the virtual machines. It'll install WordPress on top of those. It will build the EPGs, the app profiles in the tenant that we've told it. It's going to do everything. There you go, back to our 192.168.3 network. So the permit to CCC, I mentioned that one just before. That's to allow those virtual machines that get deployed to talk back to the Cloud Center instance. And at this point, that app is now being deployed onto the network. And you'll see it flashing away as it's installing the application. But what it will do inside APIC is that it will go and configure everything. So you'll see the app, the containers, if you like. So the app profile has already been configured. So this, as I'm talking, these might be popping into the UI. It's then going to go and configure the contracts. It's going to put the contracts in place between the EPGs. So it's going to build all of that on the fly. It's ahead of me. It's that quick. It's making API calls. It's very quick to configure. And once all of this is up, what it's going to do is then deploy the virtual machines on top of those port groups, on top of those EPGs. And as a network person, you've done nothing apart from build a tenant on the fabric that they can use and build an IP subnet that they can consume. All of the names that they called, did you call it DS2 or something like that, did you, for the EPG? So all the names that the app person wants to use, they're relevant to that person. So they don't need to think, OK, well, the network guy called it VLAN 10, but to me, that's my application layer. They just choose what they want to call it, and it goes and configures that automatically. So I guess they won't be up yet, are they?
And this is it, we're now waiting for the application.
We might be coming up.
VMs to spin up and for the app to deploy.
There you go.
So you can see here.
So I'll skip forward past the video, because what we'll see, once the app is loaded, WordPress will be up and running on the network. So we've completely now abstracted everything that you would have otherwise had to be involved in this whole change control loop, this cycle that everyone in the network team is stuck in, that is now gone. We don't need to do that. And I know this is hard for network people, is just give control to somebody else. Just let them do what they want to do on the network. Keep control of what is networking, what is the subnets, BGP, OSPF, actual connectivity. Like, who wants to configure a port group on a vSwitch? It's time-consuming for nothing. So really give that away. Who wants to control the ports that are open and make all these firewall changes? If we set gating processes in this whole deployment mechanism, what we'll be able to do is then control, and you'll get email updates, and you'll get alerts that says, this has been configured, this is up for approval, etc. So all of this will be configured and done automatically. And really, as network people, you've automated the whole process. So whilst that's still deploying.
At 4 minutes.
4 minutes to go? OK. What you'll see on the GUI, just in the interest of time, is this. So we saw the EPGs and what have you were created. It will build all the contracts for me. It will deploy everything. And we will wait, because we've got time for that to be being deployed. So I'll just go through these and reach the end. So, is it coming? Oh, there you go.
The ACI is configured, but it's still
building the VMs.
Deploying the application.
Yeah. So, summary. The summary is, there's no perfect automation tool. Absolutely, definitely, 100%. There's no perfect tool, because there's no tool that everyone will want to use. So really, you need to think of the tool that is best serves your users. You know, who's going to use this? Who's going to accept it? When you, as an audience, start to think about configuring, use Postman, use Visori, start pushing things in, start making these API calls. Start doing things like make an API call that looks for every interface that's got errors above a certain percentage, and pull that information out of the network. Anything that is boring or time-consuming or repetitive, is it still going? Nearly done?
30 seconds, all right.
30 seconds.
Here we go.
So we can automate all of those tasks that you do. Ta-da! That's your ta-da moment. We now have WordPress deployed on the network with zero involvement, Steve's site, with zero involvement from the network team, other than that we configured a bridge domain for them. So that is the summary. That is the end of the session. And I'm actually ahead of time, which is good, as I've got a flight this afternoon. So if there's any questions, we can take questions because there is time. There is a WebEx team room. Please, if you could fill in the survey, it is really important for us. 5s are definitely good. I didn't say this up front. So today's my birthday, so 5s are a good score for my birthday. So if you could fill in the survey, post the questions that you've got. I'll put in the GitHub links again into the WebEx room, and you can pull down all of the stuff that we've configured. And I just need to put the disclaimers at the front, the standard Cisco disclaimer. Yeah, and that's it. Complete your survey, please, if you could do your surveys. And then I'm sure you've got lots more sessions to go to. But I'm going home to get drunk tonight. And thank you very much for attending. I hope it was useful for you. Done.